Viewers, welcome to add-on. In this question, we are asked three conversion process. One is from binary to hexadecimal, another is from decimal to hexadecimal, and another is from octal to decimal. So let's start with the solution. So the first conversion process is conversion of binary number into hexadecimal number. So the binary number which is given to us is 1101.11010.101 with a radix of 2. So now in order to convert this binary number into its hexadecimal equivalent, we need to take group of 4 bits. Okay, like from this portion we will take group of 4 bits, and from this portion we will get group of 4 bits. Okay, and it may arise that the binary number which is given us here, we can't take group of 4 bits from it. Like if the binary number here, for example, I am saying that if the binary number is given 101 and we are asked to convert it into hexadecimal number, we can't make group of 4 bits because there is only 3 bits given here. So in order to make it 4 bit, we will add 0 at the front, because adding 0 at the front will make no change in its value. So we can write 0 at its front, because writing the 0 at the front and not writing anything will be the same, right? Because overall the positional weight of this bit will be 0, as the bit is 0 here. So one thing we should note, that if the binary number which is given to us, if we can make a group of 4 bits from it, then well and good. But if we can't make a group of 4 bits from it, we need to add 0 at the front to make it a group of 4. Like in this case, here the number of the bits are given here are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? But we can't make a group of 4 bits from 10 bits, right? Group of 4 bits from 10 bits, because from 10 bits, if we make one group of 4 bit, uh, from 10 bits we can make one group of 4 bits, then we can make another group of 4 bits, then 8 bits are taken out from here, so the number of bits are left will be 2. So this remaining 2 bits, from this remaining 2 bits we can't make a group of 4 bit. So in order to make a group of 4 bit, we need to add 2 zeros at the front, because here the bits which we are left with will be 2. So in order to make it a group of 4, we need to add 2 more bits to it, so we will add 2 more zeros at the front. So we will write 0 0 1 1 0 1 0 1 1 0 1 0. Now we can see that there are 1 2 3 4 5 6 7 8 9 10 11 12. So now we can see that there are 12 bits present here, so we can easily make um, 3 group of 4 bits, right? So let's start the grouping. So first group of 4 bits will be 0 0 1 1. This next group of 4 bit will be 0 1 0 1. This will be this. Next group of 4 bit will be 1 0 1 0, which will be this. Okay, so next will be, we will convert each of these groups into a hexadecimal equivalent, right? So this will give us, I guess we are all familiar with the positional weight concept. Like for a 4-bit number, if we can say this is a 4-bit number 0011, for the least significant bit, for the bit on the absolute left hand side, sorry, for the bit on the absolute right hand side, there is a positional weight of 1. And then as we progress on the left hand side, the positional weight will go like this: 2, 4, 8, 16, and likewise in the multiple of 2. So here in this case, if we multiply the positional weight with the bit and then add it together, then we will get 8 into 0 plus 4 into 0 plus 2 into 1 plus 1 into 1. This will give us 2 into 2 into 1 is 2 plus 1 will be 3. So this will give us a equivalent of 3. Similarly for 0 1 0 1, if the positional weights are 8 4 2 1, this will give us 4 into 1 plus 1 into 1, which will give us 5. So this will be equal to 5. And 1010 1010 will give us 1 into 8 plus 2 into 1, which will be equal to 10. So this will give us 10, but in hexadecimal number system we write 10 as a, so it will be equal to a. Okay, so it will be equal to a. And similarly for the right hand side of the decimal point, as I have seen earlier, that this is a 3 bit, so we can't make a group of 4 bit for it, so we will just add 0 at the absolute right, because after decimal point there is no significance of 0. So if we add this 1010, so the positional weight will be 8421, so the conversion will be same like this, so it will give us 8 into 1 plus 2 into 1, which will be equivalent to 10. So our hexadecimal equivalent will be 35A.A with a radix of 16. So this is our required hexadecimal number, right? So our next conversion process is decimal to hexadecimal. Decimal number is 35.726 with a radix of 10. We will need to convert it into its hexadecimal equivalent. So we need to just take care of the integer part, which will be the number on the left hand side of the decimal point, and we need to take care of the fractional part, which will be the number on the right hand side of the decimal point. We need to divide the integer part by the radix of hexadecimal number, which will be 16, and we need to multiply the fractional part with the radix of the hexadecimal number, which will be 16. And for the division process, we need to keep the track of the remainder. So in this case, if we divide 35 by 16, it will give us a 2 and a remainder of 3, and after that the division is not further possible. So if we keep the track of the remainder, it will give us, for the integer part we are getting an equivalent of 23. And now for the fractional part, we just need to multiply the fractional part with the hexadecimal radix, which will be 16, right? And after multiplying with the radix, we need to take out the integer part from the product. Okay, like in this section we can see, when we are multiplying 0.726 with 16, we are getting 11.616. Now as I have said, we need to take out the integer part, so we will take out 11, or we can say b, as 11 is equivalent to b in hexadecimal. Similarly, we will multiply this product with 16 again, so 11.61. So we will multiply the fractional part of the product, which will be this. So we will multiply the fractional part of the product into 16. This will give us 9.816. We will take out again the integer part, that means we will take out 9, and we will multiply the fractional part with 16 again. So 0.856 into 16 will give us 13.696. so we will take out the integer part from it, and we can continue the division like this, but it will give us repetitions, so we will stop the multiplication at this point. So the fractional part, for the fractional part, our equivalent will be, here we have taken b, here we have taken 9, here we have taken d, and 13 in hexadecimal is equivalent to d, so here we have written d. So for the fractional part, we are getting an equivalent of b9d. So this is our equivalent hexadecimal number, which is 23.b9d. okay, and now for the third problem. In the third problem, we are asked to convert this octal number 206 with a radix of 8 into decimal equivalent. So for this conversion process is relatively easy. We just need to learn about the concept of positional weights. In this octal number, the number which is present on the absolute right hand side is the most significant number, which is 6. No, sorry. The number which is present on the absolute left hand side will be the most significant number, which is 2. And the number which is present on the absolute right hand side will be the least significant number, which is equal to 6. Now, the positional weights for this octal number will go like this. For the least significant number, we will get a positional weight of 8 to the power 0. And now as we move towards the left hand side, the positional weight will increase by a power of 1. So for 0 we will get 8 to the power 1, and for 2 we will get 8 to the power 2. Now to convert it into its decimal equivalent, we just need to multiply each of this number with its associated positional weights. Like we need to multiply 2 into 8 to the power 2, 0 into 8 to the power 1, 6 into 8 to the power 0. And we just need to add the product together. So we need to add 2 into 8 to the power 2 plus 0 into 8 to the power 1 plus 6 into 8 to the power 0. So this will give us 8 to the power 2 is 64, 64 into 2, this will be 0, and 8 to the power 0 is 1, so plus 6, so 64 into 2 will be 128, 128 plus 6 is 134. So this will give us a equivalent of 134 in decimal number system. Thank you.